Hi everyone, I'm back with third video of microservices deployment series. In this video I shall be covering Kubernetes Ingress. Then we will be talking about Kubernetes dashboard and Grafana dashboard and what are the options available with Grafana repo. Then we shall be talking about cluster autoscalability and horizontal pod autoscalability. So let's get this started. So first we will start with namespace. Let me jump to the folder. So what is namespace? Namespace is a logical boundary where you will be deploying your all the components in Kubernetes. So where exactly we are deploying at this moment? So whatever we have deployed, there is already a default namespace created for you. So if you don't mention any namespace, that will be deployed inside that. Let me show you. So when I'm saying kubectl get all, so whatever listing is coming out here is coming from default namespace. If you want to see all namespaces, just execute the command kubectl get namespace. Now see, these are the namespaces already created. Some of them are created by system itself, and some of them I have created during my testing. So kube system is the namespace which is created for keeping the all the components required for running the system, and couple of the namespaces I have created. This is the default one. So if you don't mention any namespace, everything goes inside this namespace, right? So what is the benefit of this? So for example, if you want to deploy a couple of applications, maybe 2 or 3 applications, it's always good idea to create a separate namespace for them and go and deploy them inside that namespace only. The benefit you will get is that if you want to delete everything, you just go and delete the namespace and everything inside that will get deleted. Alright. So let me create the namespace for you. The command for creating a namespace is kubectl create. Either you can give the complete namespace or you can use the short word ns and you can give a name, any name. I'm giving my namespace. Alright, now let me list it again. See, so this is the namespace. But now if you want to deploy something inside this namespace, how would you deploy that? Let me list down the deployment file here. So what you need to do is that wherever you have mentioned the name inside the metadata, either in the service or in the deployment, just mention a tag namespace, and the namespace whatever you want to mention here. Alright, if you don't mention anything here, it will go to the default. So let me deploy this. Command is same, kubectl apply -f deployment.yaml. Both are deployed. Let me test. Now I'm giving kubectl all without mentioning any namespace. So this command will get executed inside default and nothing is listed. Now if you want to see inside your namespace, you need to mention -n and namespace, my namespace. Alright, though it's creating, but it is inside the namespace you have created. Alright, so you got an idea of namespace. I shall be using this namespace when I'll move forward, because when complexity will grow, I'll ensure that everything is deployed in a proper namespace. Alright, let me delete it. So to delete it, either you have a choice to go and use the same kubectl delete command, or you can directly go and delete the namespace. It will delete everything. So let me delete the namespace. Kubectl delete ns and then my namespace. It will take some time because it will delete the objects inside that, inspect it, and then delete your namespace. Alright, this is deleted. Now one thing I missed during my last session is the Replica Set. So we discussed that whenever you deploy something, any object, any deployment object, right? So it deployed three things. One is your replica set, one deployment itself, and one is event. So replica set ensures that whatever the desired number you have mentioned, based on that it will run number of pods there. Okay, now how would you scale it? So one way is that you go and create your deployment file, make changes there and redeploy it. And second thing, you can tell replica set to change the number of desired pod required. So the command for that same is, let me deploy something for you first. I think I have a deployment file. Okay, we'll use the same one. So we were inside the namespace. Let me modify the file. I'll just delete the namespace part here. Or maybe I can just disable it using hash command. I'm doing this because I have just deleted namespace. So I want to deploy this inside my default namespace. Alright. kubectl apply. This is again deployed. Since I have deleted the namespace part, it will be deployed in default namespace. Alright, now see, one pod is running. The reason being, in the deployment file I have mentioned only one replica set, right? What if I need to go and change this number? I want more replicas to be deployed. The command is pretty simple. You need to give command kubectl scale replicas. How many replicas? Say I want to run 3 pods, and then your name of deploy keyword. You can also mention the complete name deployment or deploy, and the name of your deployment. In this case, this is the deployment name. Execute it. Now again go and check. So now 3 have started getting created, and thus this number has changed. Alright, let me delete it. So I'm doing the cleanup activity after each deployment. What next? Next we will run ingress. It's pretty important concept in Kubernetes. What exactly ingress is? If you remember, we use the deployment file to deploy our pod, and then we use inside deployment we use service to expose your service using 3 mechanisms as of now. One is a cluster IP. So if you are exposing your service as a cluster IP, that is accessible inside the cluster only, or you can use the node port, which maps your your node's public IP to these cluster IPs on a particular port. Third mechanism which we used was load balancer. So what load balancer does is that it creates a load balancer and let you access publicly the service. Now where exactly this load balancer got created, it depends on where exactly you have set up your cluster. So since we have set up our cluster in AWS, so it uses AWS load balancer, that is ALB. Now why you need ingress? The reason is pretty simple, and basically there's two reasons of this. This ensures that whatever you expose, whenever you expose your service as a load balancer, it directly don't let load balancers to access service. There is intermediate layer created known as Ingress, which let your load balancer to talk to Ingress, and then Ingress internally talks to your service. What is the benefit you are going to get out of it? The first benefit is that whenever you make any changes in the service, if you are directly exposing service as a load balancer, your load balancer will get affected. It will, for example, say it is deleting, it will get deleted, and if you're recreating, it will get recreated, and that's a costly resource, because it's not something can be created on fly. It usually takes some time. The second most important benefit you get is that, for example, say if you have exposed 5 application component or 5 microservices, and you all need to expose publicly. If you're exposing that load balancer directly, there will be 5 load balancer getting created for each service. Again, that's a costly thing, right? No, there's no harm doing that, but again, ending up creating 5 load balancer which can be handled by your single load balancer doesn't make any sense. So what Ingress does is that Ingress let you talk to your load balancer directly to Ingress layer, and then from Ingress layer you can talk all 5 services. So basically you end up with creating a single load balancer for all 5 services which are deployed internally in Kubernetes. We'll see how we can do that, but before that you need to set up Ingress. So there are different Ingress available at this moment. So whenever and whatever environment you are using, you need to go and set up Ingress for that requirement. So we need Ingress for our ALP, which is a AWS component. So there's a documentation available. You need to access it and follow it to go and deploy Ingress ALP and enable it in your system first. I'll show you the URL, and I'll give the URL in description window as well, so that you can go and access it. So this is the URL. You need to follow each step carefully to ensure that Ingress is set. Right? So ALP Ingress controller on Amazon AKS. So there are multiple Ingress, as I mentioned, right? Based on your requirement, you can go and set up it. Since we are working with AWS, we are setting with ALP, right? So there are multiple steps there. You need to follow it very carefully, step by step. I'm not going to do this activity. It's time consuming, but you'll end up setting up if you're following the steps carefully, right? All right. How would you verify once Ingress is set up properly? This ALP is set up properly or not? So there's a command there. You can go and verify it. Simply, you need to check the component. As I mentioned that the namespace kube system is where exactly all the system related pods and objects are deployed. So we can go and verify that. Let's get all. Kube system. I'll show you the component related to. So see, there's a deployment done. So once you will set up it, you will end up with finding this component here, and there are multiple associated component deployed here. All right, it's running. It means it is already set up. Now we'll deploy the components and then see how this works, right? So let me show you the deployment file. I'm opening all the files in Visual Studio Code. Now these are my files. First applications, these are pretty similar, right? I have created deployment for different applications. So in the first deployment, I have created one order service, right? Then order service, is getting exposed via node port. And then inventory service, payment service, these are consumed by order service, and they're their deployment file. In the second deployment application, I have created a new order service. What I have done, I have taken a copy and I'm using a new inventory here. Rest of the things are same, so that you can understand the difference. So basically this is a new order service and there's an order service. So basically I'll end up with exposing two different endpoint using the same load balancer. That's what I wanted to test, right? And inside this, to understand the differences, I have used the new inventory. If you can remember, I have already used this, so it will print a different message like a new inventory, and here from inventory it will be printed as a inventory. Okay, so we'll be able to see. Now let's start with the one application ingress. So basically I have one application and I want to expose via ingress and then ALB. So this template you can find online, right? If you face any issue, just put your comments, share the link with you. So here the kind will be of type of ingress, and this is you can give a name here, order ingress namespace. If you want to create it inside a particular namespace, you can mention over here. This is important because this is related to the ingress you have created. So my ingress is going to be created of ALB type, which I have already set up, and this is going to be internet facing, right? Now this is the most important part where you say that how these things is going to be mapped. So basically what you say that when call comes to this ingress at root level, it is going to call my service, which is order SVC. Remember the service discovery we talked about? So basically the service name is being used and the port is being used. Okay, let's go and deploy it. So we will deploy first kubectl apply -f, the first application, which is order service and associated service. Okay, now we will deploy ingress one app. Let's see if all components are deployed correctly. Yeah, so all are running, right? To list down your ingress, using the get all, you will not get the list of your ingress command. Kubectl get ingress. So this is ingress created, order ingress, remember the name. And by default, if ALB is created, that is a load balancer is created, you will find the address here and the port number here. If you see the name, it's ALB amazon.aws.com. Just copy it and let's try to access on port number 80. That is at the root of this URL. It will take some time, but let's try if it is already created. No, let's pause for some time. Once it is created, we'll come back. Yeah, it took almost a minute. Now this is created. Okay, so I'm calling the order service, which is internally calling the inventory, then payment, and then dispatch. All right, let's come back. Now what we are going to do, this service is already there. We are going to deploy the second service, which is a new order service. Internally it is calling a new inventory, right? And then we'll change our ingress. Kubectl apply -f, my second app. Now let's delete the ingress. Let's verify it. Ingress is deleted. So the ALB, if we try to access it again, it will throw exception. It's trying to load, but in some time it will throw the exception. All right, let's try to first understand what exactly in the second ingress. So basically what we are trying to do, we have deployed two services, order and new order, right? And using the same ingress, we'll expose that with single ALB. So this is my second ingress multi-app. So this part is going to be same. The only thing is that the specs part where you will be defining, your path. So what I have done is that /order, I'm exposing the order service on port 8080. So this is a service discovery name, and on new order I'm exposing this new order, and at root I'm exposing the order SVC again. So if you're not giving any path, it will access the order SVC, or if you're giving order, it will access the order SVC, or otherwise it will in new order it will access the new order SVC. One thing to note here is that the path forwarding is not done by this ingress. So whenever you access /order in your application, also in your APIs also, or in microservices also, the call will go to /order, and your application should be in a position to understand what exactly it is asking for. For example, say if you have exposed any method on only slash, that is root, right, that will not be converted from order to root. So your application should be either listening and order, or you need to do your path forwarding using some other mechanism. So what I have done inside the order at the root and inside the /order, I'm listening to the same method, and I'm printing the same message. Same holds true for this new order and /root. Hope you are getting this. Alright, let's go and deploy it. kubectl apply -f ingress multi-app. So if everything goes well, it will start creating the see the address. If there's anything wrong with the proper mapping, the mapping which you are doing with your application, you will not see this. You will see it as a blank. So you need to just, in case if you're not seeing the correct address, just go and verify if you have done the mapping correctly. Okay, let's try to access it. Most probably it is not available immediately. It will take another 1 minute, but let's try to access it. Yep, let me pause here and then I'll come back after 1 minute. Alright, so now see, I have not given any path. It means it is accessing at root. So basically I have just mapped with the order service, so same thing is getting called. Let me give the path of new order. Now see, this new inventory was configured with a new order, so that's why you are seeing here. Now if you go with order only, see, order service is getting called. Alright, so this is the benefit of Ingress. I highly recommend you, if you are going for the actual production deployment, leverage Ingress rather than going and exposing your service directly with load balancer. Right, a lot of things can be done using the Ingress. So rather than going and creating a multiple load balancer and paying for them, it's always good idea to get a one load balancer created and get your mapping done inside internally through service discovery. Alright, so what we are going to do next, let me just do the cleanup first. First tab, alright, so these are getting terminated. Now the next thing which we are going to learn is dashboard. So whatever we have done so far, we are using the CLI, right, to deploy it. And if you want to visualize, there's another mechanism you can go and at least the node part or cluster part, you can visualize using AWS console. I don't want to cover the console part at this moment. What I'm talking about here is a dashboard. So there are multiple dashboards available in Kubernetes using which you can visualize your components, either cluster related or maybe pod related or maybe some other more information depending on what kind of dashboard you are setting up. I shall be covering two dashboard here. One is a Kubernetes dashboard, standard dashboard, and one is a Grafana. Right? Let's go and discuss the Kubernetes part. So basically there are a couple of steps you need to take when you go and deploy the Kubernetes dashboard. I have already deployed it, but I'm going to follow the process again so that you can understand it. So basically when you go and deploy the Kubernetes dashboard, you need to ensure that a couple of things are installed, like gzip and tar required, because that is required to uncompress the files which you are going to download here. These steps which I'm going to follow here, they are available in the GitHub. So I've already given a link. Just go and clone it, and inside that process document you will find all these steps. So I'm going to follow step by step. So what exactly I'm doing here, I'm setting a URL to go and get what's wrong. Okay, so one command was JK was not there installed in my system. Somehow this got deleted, so I've just installed it again. Let me fire the first command again. Yeah, and then you need to deploy metrics. So metrics is a server which will take all the required details, a kind of log system. So whatever happening in the cluster, that will go and get inserted inside the metrics, and whenever you create the dashboard, that will talk to the metrics and fetch the information and visualizes. That's the whole idea. So basically for any dashboard you need a metrics. There could be a multiple kind of metrics used in the system depending on which dashboard you're using. Kubernetes usually use the default metrics servers, which I'm going to deploy here. So next is metrics deployment. So this is deployed. Let's verify if metric service is deployed. So as usual, the metric server will be deployed inside my kube system. So we can verify from there. Is there, right? Now it's time to deploy the dashboard. Just don't try to take a note of this, commands which I'm firing. These are the steps already, given in the GitHub in a particular folder. So just go and, clone it, and then you will be able to see the process. So this is deployed. Before executing the next step, let me just brief you a couple of the things. So whenever you deploy something, anything inside the Kubernetes, there's a security model works, right? Which is known as role-based access control. And there's another level of security which is required to get access on the resources which is there in the AWS system. Since we have done the deployment of nodes inside AWS, so this both security need to be in a coordination with each other. So AWS security is controlled through IAM policies, wherein the Kubernetes security is controlled through RBAC, which is a role-based access control. In this session I'm not going to cover the security part, but why I'm mentioning this here is that whenever you go and deploy something like dashboard, you need to ensure that security is properly enabled. So in the next step I'm going to provide that security related stuff. I can show you the file, just don't get confused here and just don't try to jump into understanding as of now. To keep it simple, you can find those commands already created for you, which you can execute. But once you are comfortable with the Kubernetes initial understanding, then probably you can go and deep dive and then try to understand how this security works in coordination with IAM policy. I'm anyway going to prepare a separate video for this, right, once this series is over. So let me show you the next command where I'm going to fire which is required to access your dashboard. Maybe let me open that in the code. Okay, just cite this one. Right, so this is required, right? If you see, this is the role-based access I'm defining here, and the name of this admin is going to be EKS admin, which we'll be using to access our dashboard. I'm not going to explain it as of now. We'll create a separate video and then we'll try to understand this. Alright, so I'm going to just apply this. Meanwhile, let me open another terminal. New tab. Let me change the font size. Alright, now how would you get your token? We'll discuss in some time, but let me access it. So to access this, your proxy need to be running. So let me first run the proxy here. Okay, proxy is started. Now let me access the this dashboard. So there's a URL at 8001. Yeah, it's coming up. So at this moment, I'm using the proxy to access this temporarily, but there are the mechanism where you can go and get this deployed permanently through load balancer and then access it without proxy. Now there's a two-way you can access this dashboard. You can log in two-way dashboard. You can generate the token temporarily and then use the token to log in it, which I'm going to do at this moment, or maybe you can go and configure your kubeconfig file which can provide the token at the runtime, right? So to generate the token, you need to execute one command. Let's generate the token. Copy this token. Be careful when you're copying token. There should not be any additional space. Okay, I'm clicking on the token and signing in. Okay, so now this is the dashboard. So what exactly this dashboard is, which kind of information it is going to give you. So whatever you are going to do with the cluster, your cluster related details will be available, and some kind of logs will also be available with you if something goes wrong with your pod or any other component. But so it is not going to give you information from your container, right? What is happening inside the container. It is going to give you cluster level details, maybe pod related details, but not what is happening in your application. So there'll be different log mechanism altogether. We will cover in the fourth video. Okay, so let me just quickly walk you through, right? So this is a service at this moment running. I'm not deployed anything. Let me do one thing. Let me deploy something so that you can see it here. So let's see, at this moment there's one service running. You can see the cluster roles, RBAC I was talking about, namespaces you have created. Okay, the nodes which are running, kubectl get nodes. These node details are there. If something is wrong, you will see either Ember or maybe red here, or these are the CPU and memory, every CPU utilization across all nodes. This is the namespace. You can click on any particular namespace and then see the details, and some other details like how many pods are running, what are the replica sets are running, and some more details, ingress, services kind of thing. So let me just do the deployment. For example, see if I'm looking the pod, there's nothing because nothing has been deployed here. I've deleted everything. So let me deploy something for you. Okay, there's nothing here. Let me go. Okay, deployment is done. See here, if you click here, you can see some log information, some other details related to some event related details. All right. Even if you want to deploy something, for example, say you have selected default here, so you are seeing the default thing. If you want to deploy something, or if you want to execute your YAML file, you can also go and do it from you're clicking this plus button. Not a good idea. It's always recommended to use the kubectl command, but there's a mechanism you can do it. So the basic related details is available here. All right. Let me delete what I have just deployed. Alright, so next dashboard which we are going to see, which is a more sophisticated and more detailed information is available, is Grafana. So again, as I mentioned, right, whenever you go for any dashboard, you need a metric server. There are mechanisms available using which you can use the existing metric server, but the most famous metric server used for Grafana is Prometheus. So we'll deploy both, and then we'll see how Grafana can be used. Grafana is an open source, so there's already a site available where different kind of dashboard is available. You can go and configure it as per your requirement. We'll configure one or two and then see how it works. All right, so it's more configurable. Let's go in the Grafana folder. So let me show you the process. I've already done the deployment, but I will show you the components what need to be deployed here. So if you follow the Grafana, right, basically I'm using the Helm chart. Helm I'm going to cover in the next session, next video in fact. But again, if you want to go and deploy it, setting up the Helm is not that big deal. You can go and set up, and using the Helm will be doing the deployment. So first I'm deploying the Prometheus, then testing it, then I'm deploying the Grafana, right, then generating the credentials and accessing it. And inside the Grafana there are multiple mechanisms, right? You can go and set up a dashboard of your choice. So basically Grafana has already a repository available. If you access it, a lot of dashboard is available created by open source community. If you want to access AWS related stuff, you can go and search it and then find use or configure. See here. So Grafana can be used for multiple purposes. Okay, we will be using one dashboard here, which is the code for example, say if you're using this one, any particular dashboard, there's a ID available here, 121 in this case. What we are going to use is the 3119, which is dashboard which can give you details about your cluster, right? To access Grafana, when first deployed, it is created or deployed inside a namespace Grafana. So let's first see and list it down. kubectl get all -n Grafana. This is the namespace Grafana. Now see, this is a service created. By default, it is not deployed as a load balancer. What I have done that once deployment is done using cluster IP, I have gone inside that and then changed the cluster IP to load balancer, and that's where you are seeing the load balancer here. So we'll access using the load balancer directly and see how Grafana looks like. Okay, yeah. So I'm inside the Grafana, and you see, if you have created any dashboard or configured it, you will see over here. So the dashboard which we are going to configure first is 3119, right? The mechanism for that is click on the plus, then import, keep the number, right? Then use the what backend you are using, that is your metric server. Since we are using Prometheus, you will need to go and select over here. and import, and we are done. So your dashboard is available. So you see that the standard dashboard doesn't contain in those much information. On Grafana dashboard you can find more information, right? And since a lot of dashboard is available as per your requirement, you can go and configure it, import it from their dashboard site. So let's try to configure some more dashboard from repo. So this is the Grafana repo. Let me search for EKS here because we have done our deployment on EKS. So we'll be using the same kind of dashboard. This is LXD Kubernetes API server, Kubernetes cluster. I think we have already configured it. Let me search something else. Let me search Kubernetes. Yep. So there are multiple, right? You can go and deploy anything. Maybe this one. Let's try this one, analysis by pod. So this number is 6879. We'll copy this number. We'll go to the dashboard plus button again. Let me save the existing dashboard. Plus import the number here. Load. Okay, and here we need to give our data source. Import. Fine. So see, it has a different visualization altogether. You can go and deep dive and then understand what is more suitable in your case, and you can go and configure it. Okay, now we'll see how auto scaling works in Kubernetes, right? As I mentioned in my first session, why I decided to go and deploy that Kubernetes on EKS. The reason is auto scale. Though auto scalability is available in Kubernetes, but if your infrastructure is not auto scalable, that really doesn't make any sense. Your system may ask for more resources wherein you need to go and manually add more nodes there. Wherein if you on EKS, that infrastructure can auto scale, and that's where you will be able to achieve auto scalability at pod level as well as at infrastructure level. So we'll cover two auto scalability feature here. One is a horizontal pod auto scalability, wherein if your pod resources are going beyond a particular limit, a new pod will come into play to take the load. So we have done this manually using the scale command. If you can remember, I started my session with kubectl scale command, where Replica Set you can go and make changes, but that is not something you can go and do on production on day-to-day basis by just verifying the load if more pod is required. You can enable the auto scalability feature, which is known as a horizontal pod auto scalability, and you can define some policy that okay, CPU and memory utilization for a pod is going beyond certain limit, go and add more pod. All right, let's jump to the auto scale folder. So what is required for HPA, which is a horizontal pod auto scalability? The minimum requirement is the metric server should be up and running. So during my last session, in Kubernetes dashboard deployment, I have already deployed my metric server. So that is going to be, provide the required details for horizontal pod scalability. Nothing more is required, right? So we'll be going and enabling the horizontal pod scalability using our kubectl command. Okay, so let's first deploy a pod. Let me open the process file which I have created for you. So let me take an example, right? This command is going to deploy a pod with HPA example, run PHP. So PHP is a web server which can be accessed on a particular port. Here we are using the port 80. So we are directly going and deploying. We are not using the our deployment file as of now. Just for testing purpose, we are simply going and using the run command and deploying it. Right? So kubectl run php apache is the name, and the image I have taken from this repository. And I'm just requesting a 200 CPU, right? You can go and set the CPU requirement as well for your pod. We have not done so far, but now we are going to do this. And we are exposing this service on port 80. Let's go and deploy it. Let's see if deployment is done. Yeah, it's up and running, and service is PHP Apache. All right. Now to enable and you see that the container is getting created, but it's going to be a single pod because replica set, the desired set is given as a 1. Let's just quickly verify it if it started running. Yeah, it's running. See. Okay. So now we are going to use the auto scale command for this enabling HPA. The command is kubectl autoscale, your name of deployment, then what is the CPU and menu you want to set. So essentially what we are saying that if CPU reaches 50% for a particular pod, you can go and add more pod between 1 to 10. So this is the limit I'm going to set. And how you can monitor it, right? So the command is kubectl get HPA. So my HPA is set, which is a horizontal pod auto scalability, is fetching the information. You will see some percent, what is the running percent, and what is the target you have set, right? And what is the min pod and max pod you have set, and how many replicas getting created. To get this done, to test it, we need to put some load. So I'm going to use the busybox image. Busybox image is nothing, simply a testing image created where you can run the bash command. So I'm going to use this, right? So this is the command. You can find more details on Google. So it has started putting load. Let's verify. Still it's not increasing. Okay, now I've just came out of the command. Let me fire it again. Let's wait for a couple of seconds. So you will see the first part 0% where it is showing because we were not using this Apache server. It will start going up, and once it will go beyond 50%, more pod will start coming up. Yep, now you see. So let's verify the pod. Yep, see this one. All right, so let's close this. So this is how you will be able to achieve the horizontal pod auto scalability. So let me just brief you again. So what essentially you need is to get the HPA done, you need a metric server. You can go and deploy it, and once that is there, using the Kubernetes autoscale command, you can go and set up your HPA, and you can also set the and max pod number, the range which you want to achieve, and then for testing purpose you can go and generate the load. So I've used the busybox and then while command. You can use in any different command if you want to. All right, now let's understand how cluster level auto scalability work. So if you see, we are running 4 nodes. Actually I was running only 2, but since I was testing it got increased. Let me just reduce it so that I can explain you how cluster auto scalability works. It is already enabled, and that's why you are seeing this 4 number of nodes. Okay, so it's started getting reduced because we have already removed the load from Kubernetes cluster, right? So we were testing HPA, that's why it was increased. But let me explain you how this works. Okay, so two are scheduled for shutdown, and two are already in running state. So after some time, when you'll see, only two will be up and running. So we'll verify before executing any other command. All right. So how would you enable your cluster auto scalability? There's already a document available. I would recommend you to go through the document and follow the steps. This is a little bit complex. You need to carefully go and follow the steps to ensure that cluster auto scalability is enabled. Okay, just follow the step. These are the steps given, right? So if you remember, since cluster is already created, I asked you to include this ASG access. ASG is nothing, simply auto scalability group access. This is already given, so you can skip this part because you're not going to create a new cluster altogether, right? So you can jump to the second step and then follow the steps, post creation of the cluster. So from here you can follow the steps. You need to follow the create the policies and other stuff to ensure that this cluster is created, and then to ensure that this auto scalability is enabled at cluster level. Okay, how would you verify that? So once this is done, to verify it, you need to ensure that the cluster autoscaler is running in the kube system. So kube system is a namespace, right? So we'll ensure that by executing this command kube system logs, and then before that, let's verify in kube system if something is wrong. Okay, kubectl get all minus n kube system. So if deployment is done properly, you will see that the cluster autoscaler is running over here. The deployment is done, and the other related objects will be up and running. So if this is running successfully, it means you have done the deployment. To verify the log, right, you can fire the command kubectl and kube system logs and then deployment. So this will give the logs from this deployment, and if something is wrong, you can go through the log and verify that what is wrong. So if your cluster auto scalability is not working, then this is the mechanism you can go and verify the log. All right, I've given the step in the process document. Just go and verify it. Before putting a load, let's quickly verify how many nodes are there. Okay, so you see that now the number is reduced to 3 in fact. So 2 are in ready state and third one is actually scheduled to shut down. So actually in some time you will see that it is 2 only. So now let's go and put some load and then see if number of nodes are getting increased or not. So let me first show you the deployment file which I'm going to deploy. So I've done only one change here. This is the same file. So you see that inventory service I'm going to deploy, and what I have done that I have just added the limit, though my application is not going to use more CPU power, but just to help you understand quickly increasing the load, I have just defined the CPU limit here to 800. That is a maximum limit, and CPU which it will be consuming by default is a 500 megabyte. All right, let's go and deploy it. Let's test the deployment. Now we have defined the pod as number 2. If you see the replica set, right, is given as 2. Now we'll increase the replica set on this deployment. So it is 2 only, but now let's increase it to 10, 15, something like that. So kubectl scale replica as, let me keep a number, say 10, and deployment name is this one. Okay, let me use kubectl get all. So see, number of nodes are, pods are pending in state. Let me go and fire a command, watch kubectl get nodes, and see if number of nodes are increasing or not. So it's 2, as I mentioned. One which was in queue also got removed. Now since load is increasing, I assume at least 1 or 2 nodes should be added here. So see, 1 node is added. So as you see here, 1 node is added. Now it's ready. And if all pods are up and running and able to find the number of resources, there may be no more nodes. Let's verify. But if still something is pending and number of CPU and memory is not sufficient in 3 nodes, it will add more nodes. So see, few are pending, so we can assume that more nodes will be coming up. Right now it's 4, so it will keep adding, since we have given a limit 5, so it will not go beyond 5, but as and when required, as per your requirement, you can go and define that auto scalability part, how many minimum and maximum nodes you need, and the scalability part will take care of your resources, and it will scale out or scale in as per the requirement. All right. So till now, whatever we have deployed, they all are stateless in nature. Microservices architecture are designed, to handle stateless application primarily, but there may be a case where you want to go and deploy stateful application. For example, if you want to deploy a database on Kubernetes, not a good use case all the time. Ideally, you should be going ahead with the stateless application and database. Probably you can go and use something like RDS on AWS. But what if that is a requirement of your application, or maybe some service which need to be stateful, right? So there's a concept of known as a stateful set in Kubernetes, and we'll see how we can deploy stateful application in Kubernetes. Before that, we need to understand the storage. So if you need to attach a storage, which is essential part of a stateful application, how would you do that? There are many kind of storage available. We will cover a couple of storage, primarily mtdir and EBS volume, and I'll walk you through EFS as well, and I'll explain you those types. All right, so let's jump to the storage folder. So first we will understand mtdir. What is mtdir? So this is a temporary storage available with your pod. The scope of this mtdir is limited to a pod only. What does that mean? It means if you have created an mtdir volume or storage in your container, so container from other pod will not be able to access it. As I mentioned that the scope of this mtdir is limited to a pod, so all the container deployed within that pod can access data from the same mtdir mount point. From where this storage is available, so wherever your application is running or your Kubernetes is running, this is sourced from the host machine itself, so it is a temporary in nature, right? So for any temporary storage in your application, you can leverage mtdir. Let me show you how this can be configured. So I've taken an example of 2 containers deployed within the same pod. One may be writing data in mtdir particular mount point, and from same mount point the other container will be reading it. So let me show you the code first. So this is the pod name. And if you see, this is the mechanism how you define your volumes. So volume column, the name of volume, and the what storage type you want to leverage here. So since we are going to use the empty dir, I have mentioned over here, and then same empty dir, this shared data is attached with both containers. So inside the same pod, I'm going to deploy two containers, with one with name first nginx and second with name second Debian. Both are coming from Docker Hub. And if you see, the volume mount which is defined over here is sourced from same volume, that is a shared data. Though the endpoint mount path is different from both of them, but this is from the visibility point of view within the container only. For the volume type, that is a shared data, this is going to be same. So what exactly this second is doing? Second is actually writing a file index.html, and so some data is written over there, which is actually read by this nginx, which is a web server, and we will see that when we'll call this nginx localhost, we'll be able to see the data which is written by the second this container. So let's test this out. Let me deploy it. So see, this is running. Now this is 2 by 2. Why this is 2 by 2? Because there are two containers and both are up and running. So now we need to log into this container, this pod, and inside that pod we need to log into the container. If you can remember, the command was kubectl exec, and then through bash we will call the localhost. All right. -it, then name of pod, and then since there are multiple containers, we need to mention the container name also, giving -c, that is first container I want to log in, and then bash command. I'm inside the bash. Let me call the localhost, curl localhost port 80. So now this will read data from index.html, which is written by the second container. Now see, if I'll keep refreshing, new data point will get added. If you go back here, what exactly this Debian is doing, it is simply writing hello from the second container and date and time. All right. So this is how you can access the empty dir. Once this pod is killed, whatever data is written over there will be lost, because this is temporary in nature. All right. kubectl delete -f2. Keep in mind that the scope is limited to pod only, not beyond that. All right. Okay. What if I need a persistent storage? So I want a storage to be attached with my container, which doesn't get lost when my pod is killed, or I want to share the data point or volume across multiple container. So in that case, you need a persistent storage. There are many available from different cloud providers, from on-prem. The example which I'm going to give you is from AWS. So there are two kind of storage which I'm going to show you. One I shall be running a command, and one I'll walk you through. One is known as a EBS volume. EBS is nothing, simply a kind of SSD disk which can be created in AWS and attached with your container at runtime. Okay. And then second is a EFS. So EFS is nothing, simply like a network file server which can be attached as a volume to your container. So what is the basic difference between both of them? The main difference is that EBS is SSD and its scope is availability zone only. Basically, if you see the AWS architecture, there are regions, and then the region is divided into multiple availability zones. So just to understand roughly, availability zone is nothing simply like a data center. So if you are creating a storage that is a EBS volume in one availability zone, it will not be available in second availability zone. So scope is limited to the availability zone. And if you see that whatever the node we have deployed, our node is scattered across multiple availability zone, right? So the node which we have created, they are created in all availability zone. One node may belong to one availability zone and second node may belong to second availability zone. So when we'll create our pod, this doesn't guarantee that the pod is going to be created in the same availability zone where I have created my EBS volume. What will happen in that case? So in that case, if you'll try to attach that volume, attach that EBS which is not part of the same availability zone, it will fail. So that is the biggest challenge, but there are some workaround. I'll show you how you can do that. And that's where the EFS makes more sense, which is the EFS scope is region level. It's a regional construct. So wherever you want to access that EFS in the same region, the access will be available. So let's see how it works. So I'm inside my EBS folder. Now EBS attachment as a volume, there are two category available, or two types of two types you can use the EBS with your pod or container. One is a direct way, wherein you need to go and pre-provision your EBS volume first in AWS and then go and attach it at the runtime through the your deployment file. And second is a PVC, which is a dynamic approach. So basically one is a kind of a static approach and second is a dynamic approach. We'll see both approaches. My recommendation would be to go with a dynamic approach, where at a runtime the EBS volume is created as per your demand. Okay, so let's first work on the EBS direct, which is the static way, where your pre-provisioned EBS can be consumed as a volume in container, and then we'll jump to the PVC. So let me go to the EBS direct folder. So this is the code, right? So you will first create your volume using this command. So if you see, I'm using the AWS CLI to create a volume in a particular availability zone, that is a 1A of size 1 GB, and volume type is GP2. So GP2 is nothing, simply a SSD. So let me fire this command here. Right? When I'll execute this command, kindly note that I'm creating this in availability zone 1A. Just take a note of this, and when this is created, it will give you a volume ID. You need to note it down, because this will be used when you will be referring it in your container. Let's go back to the code. So the volume which we have created is, you need to mention over here. So if you see, what I'm doing is, it's simply I'll explain what exactly this is. So simply it is the same container nginx, but I'm attaching a volume here, right? So volume name is AWS Elastic Block Storage. This is a type of volume, this is a volume ID, and this is a file type. And this volume, the name which I have given here, test volume, I'm attaching it as I'm mounting this here in the container itself, right? Now what exactly this node selector is? So we are going ahead and using the volume, that is the EBS volume already created in a particular availability zone, that is a AP South 1A, which is a Mumbai region. Now if you don't mention anything, right, as per practice, Kubernetes whenever and wherever it will find a space, it will go and create your pod. So as I mentioned, if pod is not getting created in the same availability zone, this attachment of the volume will fail, because EBS is a availability zone construct. It's not a regional construct, right? To ensure that your pod is also created in the same availability zone, you need to use the node selector and this a particular label here. So this label I have attached with a node which is which is already created and running in the same availability zone. So let me show you how I have done this. Let me find a command. So this is the command which can be used to see label already attached with a particular node. So I'm using the same kubectl get nodes and show label. So if you see, this is the first node running, this is the second node running, and this is the third node running, and these are the labels which are already given here there, right? So I have also attached my own label, that is you can find over here. So it's here. If you see, disk type is equal to SSD. So I've attached this with this particular node which is running in the availability zone 1A. If you see, it's mentioned over here in the existing tag itself. This is the region and this is the availability zone 1A, right? What if it is not done and you need to do it? So what exactly you need to do it? Just go and execute this command, kubectl label your node name and whatever the label you want to mention over here. So whatever the label you will be mentioning over here, that need to be mentioned here in the node selector. So what exactly Kubernetes will do, it will deploy this pod exactly in the same node where this label is mentioned over. And since we have created this label in the same availability zone where exactly we have created this volume, so this is going to be successful. Okay, let's get this executed and test if this is working. Is creating. Okay, so it's up and running. So let me just describe this and see if volume is attached. If there was any issue with the volume, you must not be seeing the running here. Status as a running. But just to quickly verify it, let me fire the command kubectl describe pod and pod name. To see, this is a pod description which you have just created. So you see volume is given over here and this is attached. All right. Alright, so now we are going to talk about the same EBS volume attachment as an amount point for your container, but the mechanism is going to be dynamic. So dynamic means you need to define a storage class first. So based on the storage which you are going to use, you need to define as a default storage class, or you can also go and define multiple storage class, and when you are going to consume the data or maybe volume from that storage class, you need to mention over there. If you're not going to mention anything, the default storage class will be consumed. So this first thing you are seeing, this gp2 storage class.yaml, this is the code which you need to execute first to create your storage class for gp2. This is pretty straight, and where exactly you need to mention the name and then the storage class type. And once this is created, you will be able to see storage class with the command get sc or storage class, the complete name you can mention. So see, there's already a storage class created. Simply you can fire the same command for this one, kubectl apply -f and then name of the YAML file, and this will be created if it is not already done. So you may go and create a multiple storage class. One may be a gp2, one may be some other type depending on your requirement. Since I'm going to use the gp2 only, I have created one storage class. Now how would you go and claim your volume? So the concept is known as a PVC and PV, that is a persistent volume claim and persistent volume. So persistent volume is something which is already created, that is your storage is created, that is your volume is created. So you will be able to see persistent volume through command kubectl get PV persistent volume. I have created two for different reasons. If you remember, during the Grafana we deployed Prometheus metric server, and that metric server is using these 2 volume. So when we will create third one, it will be here, but we are not going to pre-provision it. What exactly we are going to do is that we are going to create a PVC file known as a persistent volume claim. So this persistent volume claim will be responsible for claiming the volume which is required dynamically from your storage class. Let's see how this works. So basically I have created one PVC file first, which is a persistent volume claim. The name of claim is my claim, and I'm giving the access type here and the size, which is a 7 GB, right? Now this persistent volume claim will be used in my pod for claiming the volume, which is a PV, right? So everything is same. I've created the volume type, but if you see the volume is the name is a myPD, and rather than mentioning the EBS, I'm saying that I need a persistent volume claim, my claim, which is already created. So 7 GB volume size will be claimed from your storage class and will be attached over here, and you will be able to see that in the PV part. Okay, let's see and deploy it. So storage class is already deployed. Let me deploy PVC first, or let me just show you if any PVC is created already. There's no PVC, right? So let me deploy it. kubectl apply -f PVC. It's created. Now I can go and list it down. So see, it's a pending state because nobody has claimed it, and that's why it is coming as a pending. Now when we'll deploy the pod is going to claim the persistent volume through this PVC, and this PVC is going to talk to your storage class. All right, let's see how it works. -f, then pod. So pod is created. Let's see if PVC is claimed. Still waiting. Yeah, so it's done. Now see, the volume type is given over here, and the size is 7 GB. So this is in the PVC, but now if you go and query PV as well, you will be able to see there. Now see, 7 GB this one. Let's verify if pod is up and running. It's running. All right. So if you describe here, what is the name? PVC-pod. We'll see the volume type, and the name is type is persistent volume claim. All right. Now whatever the mount point is there, you can go and use the same mount point in the different container, and you can share the data if you want to. So that's the whole idea. Let's delete it. Let's delete the PVC as well. And let me execute the same PV command. It's gone because it was dynamic in nature, and the reclaim policy was delete. So when reclaim policy is set as a delete, which is a default setting, when you delete the PVC, your storage will also get deleted. There are different reclaim policy available. Just go and learn what need to be set, if you want to retain the, your volume even when PVC is deleted, so that you can attach it again, once pod is killed and create it again. All right. So that's a homework for you. Let's jump to the EFS part. Let me open all the file in EFS. The mechanism of connecting and using the EFS is a bit different because this is a different kind of a storage. The PVC is going to work with most of them, but the the source, which is going to provide or maybe access to that storage may be different. I'm not going to deploy it, just walk you through. So just don't, focus on the command part, just understand the concept, how this works. So basically for EFS, you need a EFS provisioner, and this need to be executed. I'll give you the link, and this is also available in the GitHub so that you can go and understand it. So basically first you need to do is that, what you need to do is you need to create your EFS in AWS and just copy the path and mention the path over here of your EFS volume, right? The file system is nothing, simply the first part of it. Then this is the complete full domain name. This is the region, and this is the provisioner name you want to mention. Just go and execute it. So once this is provisioner is up and running, you can go use the same EFS PVC command, that is persistent volume claim, to claim it, and then you can use the pod to go and attach the volume. So for example, say I have created 2 pod here. If you see the writer, so writer is writing on the same volume and reader is reading from the same volume. This code is very much available in the GitHub. Go and just go through that and you will be able to understand. All right. And I've also created and attached a testing text file where the process is given how you can test it. Basically when you are writing, how would you write it, and then how you will be test that if reader is able to access the data from the same storage. So that's all for today's session. In the next session, which is the final session for this series, I'm going to cover the Helm deployment, service mesh using HTO, and some log mechanism using Container Insight and AFK. If you have not subscribed my channel yet, please do subscribe and press on bell icon so that you get notified once new video is uploaded. Thank you so much.